Rahim. Dear students, today we are going to start the 7th lecture of second year chemistry, and we have started the chapter number 16, which is about the hydrocarbons. So if I go to the previous discussion about this chapter, we have discussed two topics, one about the alkanes and second about the alkenes. So in the alkanes, we discussed their nomenclature, their physical properties, and their reactions. In the last lecture, I started about the alkene, and we say that the alkenes, they are the unsaturated. So we discussed about their nomenclature, and we discussed their different methods of the preparations, their physical properties, and at the end, we started about their chemical reactions. And when we started about the chemical reaction, we said that these alkenes are unsaturated because there is one pi bond as well as and one sigma bond. So this pi bond is a weak bond and they can be easily broken and we can add something. That's why we said that these alkenes are more reactive as compared to the alkanes. So the most of the reaction of the alkenes, they are the addition reaction. So the unsaturated can be converted to the saturated by the addition of something. So in this lecture, we will discuss all the reactions of the alkene. So the alkenes show three kind of reactions: addition reactions, oxidation reactions, and polymerization reaction. So first we move to the addition reaction. And the last lecture, I discussed one of the addition reaction, that was the hydrogenation. So hydrogenation means addition of hydrogen. And we said that the alkene can be converted to the alkane by the addition of hydrogen in the presence of nickel as a catalyst. And we also use some other catalyst as well. So today, the second kind of addition reaction, that is halogenation, mean addition of hydrogen as well as the halogen. So the alkene react with aqueous solution of halogen acid to form alkyl halides. For example, this is the alkene, we have this ethene, and halogen acid mean addition of hydrogen and halogen. So one hydrogen will go to the one carbon and this Cl will go to the second carbon and double bond will change to the single bond. So it converted to CH3, CH2 and Cl. It means by the addition of halogen acid to the alkene, they converted into the alkyl halides. So this halogen acid may be different. So the order of reactivity of this halogen acid is Hi is the most reactive, then HBr, and the least reactive is HCl, then HF. So this is the called as hydrohalogenation, mean addition of hydrogen as well as the halogen. So this is another example. We have this alkene and we are going to add this HX. So this X is going to add to this carbon and hydrogen is going to add this carbon and we are getting the double bond is changed to the single bond. So we will discuss this kind of example in the next discussion as well. First move to the mechanism of this reaction. So for the alkane we said that they are the substitution reaction and their substitution reaction takes place by free radical mechanism or chain radical mechanism. But this case we are going to add the HX into the alkene. So this kind of mechanism is different from the free radical mechanism. So in this case, the addition takes place and this addition is not a single step process. It's a two-step process. And this kind of mechanism that is called as electrophilic addition reaction. For example, this is our alkene and this is the HX. We know this is a polar bond. So this is partial negative. This is partial positive. So these electrons, so negative means these two electrons, they are also negative. So they can attack on the positive part. It means this H is acting as an electrophile. So we can say this H is going to add first to the carbon. So these two electrons will add with this hydrogen. So this carbon will be electron deficient. So this will get the positive charge. So this is the first step. So that's why this is the attack of alkene on the electrophile. That's why it is called as electrophilic addition, because in the first step electrophile is going to add to the alkene and the next this negative ion will attack on this carbon and we are getting the alkyl halide. So this carbon which has the positive charge, that is called as carbocation, that will called as the carbocation. Mean this electrophilic addition is not a single step, it's a two-step process. First, electrophile is going to add, and the second carbon get the positive charge, and then this negative ion, mean halide ion, it will attack on this carbon, and we're getting the product. So this is the electrophilic addition of the halogen acid to the alkene. Next, very interesting example, and this is very important. For example, we have this alkene. If we move to this alkene, if I cut from the middle, we can see over this there are CH2, and over here there are some different group. It means this kind of alkene that is called as unsymmetrical. If we have the ethene, if we cut from the middle, both will be the similar part. So that ethene, so this is the ethene. That ethene is symmetrical because when we cut from the middle, both are the similar parts. But this alkene, this is unsymmetrical. So when we are going to add the HBr into this unsymmetrical alkene, then there are two possibilities. Either this hydrogen, either this Br will go to carbon number 1 over here, and H will go to this carbon. Then there will be this product, means CH2Br, and this hydrogen go to this carbon. So this is CH. So this is one possibility. So its name will be 1-bromo 2-methyl propane. And the second possibility is this Br goes to this carbon and H goes to this carbon. So the product will be this one, 2-bromo 2-methyl propane. It means by the addition of HBr to the unsymmetrical alkene, there are two possibilities. Then we have to decide which one will be the major product. So there is a rule, very, very important rule in organic chemistry, and that rule is called as Markovnikov's rule. And the formation of product, so there are two possibilities, and out of these two possibilities, only one product is formed. And the formation of this one product, that is on the basis of this rule, that is called Markovnikov's rule. And according to Markovnikov's rule, addition of an unsymmetrical reagent, because this HBr is unsymmetrical, addition of unsymmetrical reagent to unsymmetrical alkene, the negative part of the adding reagent goes to that carbon which has least number of hydrogen atoms. So if we are going to add the unsymmetrical reagent to unsymmetrical alkene, so negative part of the reagent will go to that carbon which has less number of hydrogen. So this is HBr, we know this Br is partial negative. So Br will go to that carbon which has less number of hydrogen atoms. So out of these two, this second product will form, and we get the 100% formation of this product. And this is on the basis of this Markovnikov's rule, and definitely it involves some mechanism through which this product is formed. So this Markovnikov's rule is always going to obey when we are going to add unsymmetrical reagent to unsymmetrical alkene. So we can use some other example, for example, addition of water, same case, addition of HBr or HX, the same case, we will apply the Markovnikov's rule in the predicting the product. Next, move to the next topic, hydration. Addition of water. Last time we discussed the dehydration, removal of water. Now this is the hydration. Addition of water, that is called as the hydration. So if we add the water into alkene, that converted into the alcohol. So if we have the water HOH, so H will go to one carbon and OH go to second carbon, and we get the alcohol. But this addition of water is not a simple, that takes place in the presence of some acid, for example H2SO4. So we add H2SO4, first it combines with H2SO4, so H goes to one carbon and the remaining part goes to second carbon. So double bond change to single bond, so it will convert into CH3, CH2 and OSO3H. That is called ethyl hydrogen sulfate. So this intermediate is formed, and then we add the water. This bond going to break, and we are getting the CH3, CH2 and OH. Now this is the alcohol. So this hydration is not a simple addition of water, that takes place in the presence of acid. And it also involves, if we have the unsymmetrical alkene, it also obeys the Markovnikov's rule. Next, the next reaction, that is the halogenation. Halogenation means addition of halogens. And now, if we have this alkene, this is the halogen, maybe chlorine, maybe bromine. So both are symmetrical. So there is no rule of the Markovnikov's. So this very simple. One halogen will go to one carbon, and second halogen will go to second carbon, and double bond will change to the single bond. And we are getting the dihalides. And this kind of dihalide, in which two halogens are attached onto adjacent carbon, they are called as vicinal. So we get the vicinal dihalide. So in other words, addition of halogen to the alkene in some inert solvent, they convert into the vicinal dihalide. Or if I read over here, the alkene react with halogen in an inert solvent like carbon tetrachloride at room temperature to give vicinal dihalides or 1,2 dihalogenated product. So bromine and chlorine are effective reagents. Fluorine is too reactive to control, and iodine does not react. So generally we use bromine and chlorine for this halogenation reaction. So we move to the mechanism of this reaction. So this is very interesting mechanism. Again, this mechanism is electrophilic addition reaction. So all the addition reaction in the alkene, they are done by the mechanism that is electrophilic addition reaction. So you must have kept in mind that the addition in the alkene that takes place by the electrophilic addition reaction. So if we move to this one, so this is the bromine. So both is, if there are some poles over here, partial positive and partial negative. So this double bond attack over this Br, and this Br negative is going to leave. And this Br, they make a special ring that is called bromonium ion. So because there was some carbon positive, so this Br attack over this carbon and we get Br positive. So this cyclic bromonium ion is formed. This is the intermediate which might be isolated, and this is detected by some technique that this kind of ring is formed. And now the Br negative, it will attack on this carbon and this bond will break, and we will get the dibromoethane vicinal dihalide, but we will get the Br from the opposite direction. That is called as the anti as well as the trans. So we will get the anti-dibromoethane. So the formation of this anti-product indicates that there is a formation of some cyclic product. That's why this Br attacks from the back side. So this bromonium ion is important. This might be given in the paper. The reaction of alkene with the bromine or the chlorine, we are getting this ring. This is the first step, and then the attack of this nucleophile on this carbon, we are getting this dibromoalkane. So this addition of bromine is a special test for the detection of double bond. So if we have the unsaturated, we add the bromine. So by the bromine, the yellowish color or brownish color will remove discharge. So discharge of this color shows that the organic compounds contain the double bond. So this test is applied for the detection of double bonds in a molecule. Next, halohydration. Halohydration means addition of halogen as well as water. So addition of hypohalous acid HOX. If we add the halogen in water, it converts into HOX. For example, this is chlorine. It will convert into HOCl, hypochlorous acid. So generally it is called as hypohalous acid. That is called halohydration. So we have the alkene. We are adding the halogen plus water. So by the addition of this, directly we get the HOX. So one carbon will get the OH and the second will get the X. So X and O. This is called as halohydrin. If this is the chlorine, it will be called as a chlorohydrin. If this is bromine, it will be called as the bromohydrin. So this kind of reaction, that is called as halohydration. So these are some addition reaction. For example, hydrogenation, halohydrogenation, and hydrohalogenation, and halogenation, hydration, like different. Now come to some oxidation reaction, and one of them that is called as epoxidation. So if we treat the alkene in the presence of some per acids mean For example, hydrogen peroxide. We call why hydrogen peroxide? Because they contain one more oxygen. Similarly, if we have the benzoic acid, its formula is C6H5, C double bond O and OH. But if we have some additional oxygen, that is called as parabenzoic acid. It means this is a source of oxygen. Similarly, we have the peroxyacetic acid, meaning this is if this is CH3, so we have one addition oxygen that is called as peroxyacid, either peroxybenzoic acid if this is the benzene ring. If this is a CH3, it will called as peroxyacetic acid. So this one of the oxygen, it is going to react with this double bond, and this oxygen comes in between these two carbons, and we are getting this kind of product that is called as epoxide. That kind of class that is called as the epoxide, and because these are 3 carbon, it will call as epoxy propane plus benzoic acid. So one of the oxygen is going to lose and it converted to the benzoic acid. So this is the oxidation reaction. So this addition of oxygen, that is called as the oxidation. So alkene can be converted to the epoxide by the reacting with per acids. They're called as per acids or peroxy acids. So per acids, because these are the source of oxygen, mean oxidizing agents. Next, very interesting, that is called as ozonelysis. So reaction of alkene with ozone. We know the O3, this is the ozone. So by the addition of ozone, this bond going to break. Carbon double bond, carbon, this is going to break, and we get the carbonyl compound. So previously there was no reaction in which whole 2 bonds are going to break. So in the previously only pi bond breaks, but now the whole both bonds are going to break, and we're getting the oxygen over here. So this is why this ozonelysis is used to locate the position of double bond in an alkene. Where is the double bond that will break and we convert into the carbonyl group. So if these are the hydrogen, so we will get the aldehyde. So because this is symmetrical, we will break from the middle. So we are getting the 2 molecules of aldehyde, and both are the same aldehyde. And if one of them, if this is carbon CH3, this is also CH3, we will break from here. So we will get 2 kind of molecule. One will be ketone and second will be aldehyde, because these are the hydrogen. So they involve some special mechanism. So look at the mechanism. So alkene react with ozone. First ozone adds, because this is O3, it makes one intermediate that is called as molozonide, and it is very unstable, and it's rearranged and convert into new thing, and this is stable species that is called as the ozonide. So now you can see this bond breaks and the oxygen become over here. So then this is called as the ozonide, and in the next step this ozonide breaks, or we reduce that one by adding the water. So by the addition of water, what will happen? This bond breaks from over here. So we are getting C double bond O, and these are 2 CH, 2 hydrogen. And similarly, double bond breaks from this direction, and we are getting C double bond O. So we get 2 molecules of aldehyde, and both are similar. This is the formaldehyde and H2O, and 1 oxygen more, H2O2. And then we add the zinc, which pick up this oxygen and convert into zinc oxide. So this is a very important reaction for the conversion of alkene into the carbonyl compound by the reaction with the ozone. So in the previous all the reaction, there is no reaction in which alkene can be converted to the carbonyl compound. But this is the way in which we can convert the alkene into the carbonyl compound. Next, last one, that is the polymerization. Means alkene can be polymerized. So what is the polymerization? Is the process in which small organic molecules, which are called monomers, combine together to form a larger molecule. So they are called, this process is called as polymerization, and the product which is produced, that is called as the polymers. And we know with the plastic bag, these are the polyethylene. Polyethylene mean large number of ethene molecules, they are combined together. So polyethylene, this is the ethene, N mean 1000 number of ethene molecule under special conditions. So this bond breaks, pi bond, and it makes a bond with a neighbor molecule. And the N mean 1000 number of alkene molecule, they make a chain that is called as the polyethene or polyethylene. So we have some natural as well as the synthetic polymers. For example, we know the proteins. These proteins are the polymers, and they are made by the amino acids. Similarly, the sucrose, the carbohydrates, they all are made up of some glucose or molecule. So they are called the monomer, that is the glucose as well as the fructose. So they are called the monosaccharides. So it means, so polyethylene, we know that we have the PVC pipes generally used. They are the polymers of the polyvinyl chloride. So you can see in the book some examples are given, some synthetic as well as the natural polymers. So this polymerization technique is very important, and we make a number of polymers. And this basic part which is used for polymerization, that is called as the monomer. And after combining the number of monomers, we get the polymers. So in short, this is the summary of all the reactions of the alkene, and this is very important summary. And I took this page from other book, and you can see this is the alkene. We are getting the add something, and we're getting the product. It means we can say that all the reactions, they are generally addition reaction, but some of them is oxidation as well as the polymerization. So by the addition of water, hydration, one carbon get the H, second carbon get the OH. Alcohol. Hydrogenation, addition of hydrogen, one hydrogen, one carbon, and second hydrogen goes to second carbon, alkane. Hydroxylation means if we are adding the K-4, we are getting the diol. So we did not discuss this reaction over here. So that was given in 10th class, reaction with the K-4. So we're getting the diol, means two OH attached to the adjacent carbon. That is called as hydroxylation. Oxidative cleavage mean reaction with the ozone, and we said this double bond breaks and we get the carbonyl compound. Epoxidation mean we have some peroxide and converted to the epoxide. Halogenation, we added the halogens and we were getting the vicinal dihalide. Halohydrin mean addition of HOX, mean one carbon get the X and second carbon get the OX. And the last one we talk about the HX, addition of hydrohalogenation. So one carbon get the H and second carbon get the X and convert into the alkyl halide. And this carbene, this is not added over here in your book. So this is the summary you must keep mind, and you can learn this all the reaction from this table. So that's all we discussed today about the reactions of the alkene, and we said all the addition reaction. So addition reaction, oxidation reaction, as well as the polymerization reaction. So if you have any question, you can send me in the comment box and we will discuss it. Thanks and good luck.